Okay, hello everybody. I'm here to mark the next instalment of the Year 10 Science homework with you. So let's get started on that. The exam was an electricity exam, and it's the second one that you've had to do, hence the name Electricity 2. So the first question, moving down the page, is to do with circuit symbols and their functions. So you need to be clear on these and others, and if you're not, make sure you go back and revise on them. It's a really good opportunity for some self-quizzing. Okay, so first one we've got, I'm hoping everyone got this, is a switch. I've just added there in blue pen that obviously this is open, your closed one is when this little bit closes and touches the other side of the switch. Then current can flow through. A variable resistor is like a resistor, but it's got that diagonal arrow going through it. Now this one is a bit of a trickier one to draw. Its name is a diode, and it allows current to flow in only one direction. And quite a nice way you can remember that is that this bit here is kind of like a forward sign, and then there's a stop there to mean that current can only flow in one direction. It's just a little trick to help you remember, so if that helps, use it. Question 4, an ammeter measures current, again hoping that everyone knows that. And the last one, again quite a tricky one to draw. The way I like to remember how to draw this is, well, LDR stands for light dependent resistor. Let me just get that on there, light dependent resistor, and there's a resistor in there, right? And these two, that's like the light coming onto it. So light resistor, the resistor depends on the light intensity around it, which is quite a nice way to remember the symbol if you know the full name for it. Alright, moving down to B. So the point in these symbols is to avoid any misunderstandings. Now you might be thinking like, okay, how's anyone going to misunderstand? Well, you know, there are lots of different scientists and lots of different electricians and electrical engineers around the world, and they all speak different languages. So if they have these symbols, it's like a shared language for them, and it stops any, you know, problems. So, you know, no one gets an electric shock or something like that. That wouldn't be a good thing. Okay, question 2. So here we go. There's our elevator. Looks quite modern, doesn't it? And this is a calculation question. So as with all calculation questions, you need to make sure you're bugging. That is your work done or energy transferred, same thing, 120,000 joules. You've got 8 seconds that it takes for that motor to work in the lift, and it wants you to calculate the power output. I've labelled and boxed all the things that I need to. Also started to list my values down here. We don't know the powers, but we're trying to work out 120 joules of energy or work done, and 8 seconds is the time. So the equation is power equals work done divided by time. 120 joules divided by 8 will give you 15,000, and the units is watts. Now these kinds of questions, sometimes they can be 2 marks, sometimes they can be 3 marks. This is a 3 mark one, and I think it's being a little bit generous by offering 3 marks for it, if I'm being honest. You know, for this one we'd say, look, you get a mark for knowing the equation, second mark for substituting, and a third mark for getting the right number. It gives you the units there. So sometimes they might just give you 2 marks for this, one for substituting and one for getting the correct answer. Then you might get another mark if you knew the unit, but it gives you the unit here. So just something to be aware of. Count it as 3 marks, but I think it's being quite generous. Alright, moving down. Question 2b. This is an interesting question actually. So let me just explain it to you. It says the power output of the motor is greater than the power input. So I've just written that down. Just paying attention here. We've said the input is greater than output. That's always going to be the case for any, let me just write that on, any machine. The input's always going to be greater than the output. You're never going to have a situation where the output, power output, is greater than what you put into it. That doesn't make any sense, right? So, if you were to put an equation, make it into an equation, you could say the output divided by the input is less than 1, right? That starts to look like our efficiency equation, and the idea is it's never going to be more than 100% efficient. It's always going to be less than 100% efficient, right? And the reason it's always going to be less than 100% efficient is because some energy is always dissipated. That's what I've written here. Now, if you read through these, this bottom one here, there's no one in the lift. That doesn't make any sense. So it's got nothing to do with it. The motor is more than 100% efficient. No, we've just said that's not the case. That can't happen. The motor is connected to the mains electricity supply. I mean, it is, but that's not why the output is less than the input. Okay, the top two, energy is transferred in heating to the surroundings. Basically, energy is dissipated. Friction causes some energy to be transferred in non-useful ways. Energy is dissipated again. These two basically say the same thing. They're saying, you know, some energy is wasted, some energy is dissipated, it's given to the surroundings. You know, maybe that's through friction, maybe that's through heating. Like heating and friction are linked, and those are your two that you need to get 2 marks there. All right, next one. So again, quite a nice question here. It shows you the circuit, a very basic circuit for the lift. You can imagine this being the switch at the top, this being the switch at the bottom, you know, when you get in and out of the lift. And it wants you to explain why it can be operated using either one. Now, if you just imagine you're the coulombs of charge going round, down here, so we start off coming out of here, round, round, down, down. I've already drawn some arrows. Right, if you were to close this switch, right, you could flow round and then complete the circuit through the motor. If that switch was open and this one was closed, then you could still flow round and get back to the other side of this power supply. And basically, only one needs to be closed to complete the circuit. So that's what you need to say. You need to well, first thing you say is the switches are in parallel, right? One there, one there. Right, they're in different loops. There's 2 paths through which current can flow through. So give yourself a mark if you said that. And secondly, so closing either switch completes the circuit. It's a 2-mark question. I'm hoping everyone got this one, but you know, use all the information given to you. Say that the 2 are in parallel as well to get yourself a 2nd mark. Okay, last part of this. So this is quite a nice link to the last thing we were doing in physics, forces and mechanics and things like that. So it's to do with gravitational potential energy. It's a calculation question. You've got some numbers, so start bugging it and labelling it. 14 meters is the height, 280 kilos is the mass, 9.8 is the gravitational field strength on Earth. It wants you to calculate the gravitational potential energy. Right, I've started to list the values here. We don't know the gravitational potential energy, we don't have the mass, gravitational field strength and height. That is the equation. Quite an easy one to remember, just multiply them all together. mgh, substitute in 280 times 9.8 times 14. That gives you this number. If you've got this part substituted and this part, that gets you 2 marks. You need to pay attention to this last bit. It says 2 significant figures, so you get the 3rd mark for 2 significant figures. So that's 38,000 joules. That's all 3 marks, right? That's the first half of the video done. I'm going to stop recording now and then do a second half for the other 2 questions.